Ha! If I just had those, my code would run fast. That's what I need to use. And they get it wrong. And you get horrible bugs, squirrely, confusing bugs, and you must simply generally deny these to most people. Another reason is that they may not play well with the debugger, because the debugger is probably engineered to work with the safe stuff and the safe metadata, and it may use reflection. And for various reasons, unsafe code in our system, and I think this was the right decision, if you used reflection to go poking around in your Java object space, you just didn't see the unsafe stuff. It was not there. You didn't get exceptions. It simply wasn't there. Well, that's going to give your debugger kind of a problem if it's reflection-based. And the last point is one that wasn't really evident to me until I started to make this all up, which is that unsafe extensions are rather compiler-centric. In an interpreter, all of the little twiddly stuff that you do in unsafe extensions is often crammed into some larger piece of native code and runs more efficiently. Actually implementing in an interpreter the things that you say are unsafe might really slow your interpreter down. It sort of assumes that you've got a compiler, it'll do inlining, it'll see that it can optimize, and it'll have a good time and make your code go fast. So this, I guess, is my gripe with IBM and Sun. Their unsafe extensions are largely what you could call peek, poke, and jump, and a little bit more. And what they've left out that was most important was unsafe data types. All the data types that you need to talk to the OS. All of the data types that you need to talk to these different libraries. Because you can get checking. Just because they're unsafe, C has a type system. And, and if you're really, really careful, you don't allocate memory, you don't free memory, and somehow or another you check all your array of bounds accesses, you won't break it. You don't do casting either. But then it has a type system. And so there is a type system, even for this so-called unsafe stuff. And so you should use one if you can. It'll help you catch errors. It's a little bit more interesting. You have both the idea that you allocated a data type in untraced memory, malloc and free. There is this notion of a view. And a view is actually not unsafe. This was the observation of the spin people. Their problem was, essentially, I'm writing some network protocol. Someone handed me an array of bytes. I would like to take a structure, a well-defined structure for an IP header, and slap it on that array of bytes, and that's how I want to look at it. And you could, if you wanted, load the bytes and shift them and add them and do that. And no one ever gets that wrong, and it's so much fun to read, and it's so obvious what you're doing. Why would you want views? So they wanted views. And views are safe because they're only legal if there's no pointers playing. So you can interpret integers any way you want to. So there are things that you should put in your language that get away from the need for unsafe. For that matter, compare and swap. It's not really, you have to be a little careful because maybe you have some tricky representation of pointers. So maybe compare and swap is not safe on objects. Or maybe you have to do some virtualized compare and swap. But the notion of implementing compare and swap, there's nothing unsafe about it.
They just left it out of the bytecode.
Yeah, they just left it out.
Really? It's just a box for
Not even Doug.
Another thing that you need in your
I wasn't there.
another thing that you need in your unsafe is GC interfaces. Jalapeno has some of this. C# has some of this. C# seems to have the right pinning abstraction. So go steal theirs. You sometimes need to suspend GC. You sometimes need to publish roots. This is all stuff that we ended up implementing that are not in the other unsafe interfaces. I said that we were heavily into threads. We had 3 different kinds of unsafe thread linkage, and in fact 2 different kinds of safe thread linkage. So 5 different native method invocations, depending. Unsafe extensions, you include all of the conversions, and you really would prefer to have well-defined conversions that say what you mean. You should not be adding 12 to your object, cast 12 to your object because you know that gets you to the array data. You ought to have a loophole that gets you the data view of the array, and that returns to you a view of the appropriate type given the array type. So you can say what you mean. And of course you need cas and membar. I'm hoping this won't be too long. From here on out it's examples and then I talk about encoding. So if you're doing an interface to native code, and these are all real-world examples. This is all code. First time we did FDLibM, I translated it to Java, but it runs faster in the original C, and I don't make any mistakes translating it. So why not call it as a native routine? I translated David Gay's GD to A from the C into Java, and I found a bug in it. So I had to back out the bug discovery from the Java back into the C, verify that it was still a bug in the C, send a bug report to David Gay, wait for a fix, and put the patch back into the Java. That was so much fun. And so...
Can you tell us what GD to A is?
Oh, good grief. No. It's generic, digital to ASCII. It's the one you're supposed to use. It's right.
Now.
Yeah, that's okay. The one in Java that's shipped is wrong. It's better. So that was one. ZLive, I didn't want to translate that. And I didn't want to translate the OS. And there's licensing issues. So what did we do? So we needed untraced references to pass our information to GD to A. In the case of GD to A, we pass it a buffer to put the bytes into. In the case of the OS, they like to have all of this malloc and mobile data for whatever you're doing, whether it's buffers, descriptors, IO completion blocks, what have you. We've got types, you pass it in, it's an untraced member, all in unsafe code. For ZLive, because we could see that it was just operating on a little buffer, we knew it was pretty quick. We said, nah, we'll just pin the object, and then we'll call ZLive. And depending, so this is how we pass the parameters, and then depending, when we study the code, we can run FDLibM in what you call the yellow zone. It's a piece of C code that runs so fast, and in a nice little bounded piece of stack. You don't want to bother with a change of a stack overhead. You're calculating transcendentals. You want to be competitive with the machine instructions if you can. So you do a yellow zone call for that one. GD to A and Z.
I'm sorry, what's a yellow zone?
Yellow zone. So here we are in the world of heavy thread hackery. Your thread has its own little tiny stack, 4K, with a little yellow zone. And you don't run off the end of the yellow zone. That would be bad. And there's no notification if you run off the end of the yellow zone. You just corrupt valuable data. That would be bad. So most of the yellow zone stuff is handwritten assembler. And you look real hard at FDLibM and say, yeah, that's a good.
Oh, I see. So it's stuff for which you don't have to range check because you know that you have.
You know it's, yeah, it's going to run in the few hundred bytes a stack that you've got. I can't really say that about GD to A or ZLib. So they get to run on the C stack. But I know that they run really fast. So we won't bother detaching their thread until they return. I can't start a GC. That's okay. That wasn't a performance problem. It makes them a little faster. The OS is another problem. So we give it a detached thread. So each of these is a choice you would make in your unsafe code for a linkage. And this is if you, in the particular world where you're focused on fine control of your threads. And another thing that you do when you're messing with the lock word, you're doing the standard bit with the bits and a compacting garbage collector, where 00 means never computed the object hash code. 10 means the hash code is the address, and 01 means the hash code is appended to the object. I copied it over at the last GC. Well, the lockboard has a lot of clients, and they're accessing it all the time. So you just use CAD, you pin the object, because it might move. Do the CADs and the flag bits, and then it's unpinned. So this is something you can do in unsafe code. It's a good thing to do. The idiom that we used a lot in our file I/O and socket I/O is the untraced buffer wrapper. And you will see this now in Sun's libraries, in the NIO libraries. They have the same thing. You have a traced object that can be handed out, a safe object that can be handed out to safe code, and it can talk to it and interact with it. It wraps a buffer, and the buffer is allocated by malloc. And part of this idiom then is that your buffer you have to free the buffer, because otherwise you have a memory leak. So you have to be very careful.